My name is Mary Grygleski. Actually, I was kind of, by the way, too, this is Chicago, and that's where I'm based out of. So there was just some pictures that I was screening through, but maybe I'll do it again. This is Chicago, by the way. That's where I'm based in, although currently I'm in Wisconsin for family reason, but not far. And then this is the Blue Angels, and then this is the famous bean. Anyway, I hope you can all visit Chicago. So let me kind of start again. And so my name is Mary Grygleski, and I have, oh, that's right. I haven't shared my screen yet. Okay. That is true. Can folks see me? Okay. I'm sorry. So I'll start again. This is, thank you for reminding me. And okay, cool. All right, then I was going to say I will share a couple pictures of Chicago too, but let me kind of first start this conference because otherwise I'm running late. I tend to like to talk, and let me kind of start. Okay, so folks, you can see me. Okay, so welcome again to my talk. Today, I'm going to be talking about stateful microservices, and it's built with Open Liberty and Kubernetes. Actually, the time when I came up with this title, I actually was more focusing on Open Liberty and Kubernetes then. But actually, too, is that over time, I have kind of changed the title to call it more like in the cloud native world, a little bit more kind of more generic, so to speak, right? So it applies to any type of environment where you want to do stateful microservices. So, and my name is Mary Grygleski. I'm a senior developer advocate at IBM, and really happy to be here at JCon Online 2021. So thank you. And a bit of an introduction, right? And you see that I'm using a butterfly because I feel myself as an advocate is like a social butterfly. I'm like everywhere, outreach and talking to folks. And, I'm doing a live coding stream, things like that, and going to conferences, but currently it's all online for the time being. I think just most of the places, but I hope to be able to visit, everywhere too that I can go to in the future. So I'm with the WebSphere Liberty team, although I'm not on the commercial side, but I'm more on the open source side. So my area, I'm focusing on Java, open source, cloud, DevOps, and enterprise distributed systems, in fact, is my area of passion. So, and projects that I'm involved with are Open Liberty, Microprofile, and Jakarta EE, and also a little bit of OpenJ9 too. And I have over 25 years of software engineering experience prior to becoming an advocate. I've been with IBM for about 3 years now, a little over 3 years as an advocate. So I really enjoy my work and then talking to folks and everything. I also am involved with the Java users group. So I'm president of the Chicago Java users group currently. I also help to organize a couple other IBM sponsored meetup groups in Chicago. And I like to really invite all of you to come to our meetup too. So yeah, I'll have information of all of these contact information as well as all of the meetup information too. So yeah, so again, welcome, because I know it is, especially if you're in Europe, it's already getting late in the day. So and it's morning for me here in the Midwest of USA. So, and again, let me kind of start. So my topic today, right? I like to kind of make it a bit more like less dull, so to speak. I feel that stateful, microservices, especially just stateful itself too, I feel is a bit kind of less talked about, although I think in recent years, maybe a bit more, is a bit dealing with data, transactions, and things of that nature, right? So, and in recent years too, with cloud native, everything is about serverless. We heard about, right? It's serverless is essentially stateless type of computing. So I wanted to make it a little more fun. So I was kind of trying to come up with some idea. And then I came across, right, Finding Nemo. I guess if you're a cartoon fan or you have small children, you have seen Finding Nemo. So I think, that would be a good way to kind of explain it. And I also have to make some assumption too, maybe not everybody is, here is familiar with the topic. So, and pardon me if you're already a pro and you know everything, but again, I just wanted to make sure, I kind of address the needs of everybody in the audience. So anyway, so with Finding Nemo, as we know, Marlin, right, the big orange fish, the dad, lost his little fish Nemo, and he went out into the ocean looking for his son. And in the meantime, this bluefish came, he ran into him, Dory. Now, Dory is a very forgetful fish and cannot remember anything. And so maybe now you can kind of understand why I'm using this kind of a crude kind of analogy to explain it. But I think it's kind of fun because if you think of it, right, stateless, kind of forgetfulness, kind of like that. Well, in some sense, right, in a human way, if you want to describe somebody stateless, is really they can't remember anything. Although I do have to say that I should not make fun of it. There's also medical condition, but anyway, but it's just a little kind of have a bit of a lighter way of introducing. So it's essentially, right, what is stateless and stateful? So computing life used to be simpler, stateless computing. So it is actually a communication protocol that does not require any session information to be retained, right? The state of data does not get recorded between transactions. And so as a result, right, the architecture, the design, the implementation, everything is simpler. Because if you want to scale the system, is as easy as, especially in a cloud native world that we live in now, with Kubernetes, with all the clusters, is with the nodes and pods and all of these things, you can just quickly spin up maybe a node. And the node too is just more like, okay, clean just started. No need to worry about initializing to a state that it's supposed to be. So that would be the opposite with stateful, but this is stateless. So recoverability, likewise, is also simpler, right? From system failure or whatever reason, your node is down, you need to spin up a new one. There's no need to kind of look up what is there and, spin it up. It's more like, okay, just start it without thinking. So as you can see, right, I'm using the example of Nemo. Dory is like that, happy-go-lucky, and I need to do something, just go do it. As you can see, it's also more efficient. And that's why too is being adopted, right? It's kind of like the principle, kind of specify, it for any type of cloud native computing environment these days. But realistically too, we live in a stateful world. But just think of the fact too, if you forget, your spouse's birthday, look what would happen, right? You would get yelled at, right? I mean, the fact is we live in a world that requires the state of data to be preserved, and it's like, it's no doubt about it. But I think people avoid talking about it because it's just messier, right? If you need to write code, you need to then worry about, preserving the state, going across the network boundary and all of these things. So that's what stateful computing is. It's essentially a communication protocol that would, retain all session information. State of the data gets recorded at every step across all transactions, and no matter where you go, you need to be keeping track, And so architecture-wise, design, implementation of your code base is just more complicated, right? You need to take into account all these things. And then scaling the system is also difficult. If you want to spin up another node, again, I mentioned earlier, in stateless, there's no need to worry about, finding out what it was before and then, kind of restore the state. Nothing like, well, for stateful, then you will need to, right, kind of look things up and then restore the state to be the same as all of your other nodes inside the same cluster. Recoverability, likewise, right? It's also kind of involves a lot more effort. But let's take a look. Statefulness in the cloudless days. So that would be like before cloud native, all of these cloud technology came up. Then how did we do, maintain state, right? So let's kind of go back to the time of client server systems that kind of came into being in the 90s. So at that time too, well, from the history of time, I think everything, all the computing too will need to, keep track of state. But of course, in the earlier days, there was, not that, kind of support yet. But then slowly in client server time, we're addressing the needs for preserving state. So in client server systems too, we have stateful database systems, on the server side. So we use database style of transaction, right? So we are kind of like, when we write the code, we are basically kind of, kind of letting the database takes care of transaction, right? If you're writing the code, sometimes too on your coding level, if you configure it, to kind of by default, usually too in your database engine will then be assumed to be the one that manage all your transaction. If you're doing an update, doing actually select to or insert, delete, all of these things, every time you start that kind of data manipulation type of language, then essentially too there will be transaction that starts. So if everything all goes right, then towards the end too is an implicit commit, right? If everything goes right, then database engine will then take care of committing your transaction. So and that kind of way of doing things has been kind of been like that for quite some time. And then of course, if you want to have user level transaction too, a lot of times too, you can also kind of configure your database in order to kind of enable like user level. So in your code too, essentially is that you can actually manage your transaction on your coding level as well. And then now, how about then in the case of distributed database, right? We live in a world, especially in today's world, everything is distributed now. It's not just one. We have multiple copies of databases, or not even so. It could be like, different database that are like different vendor database too, because they all serve different purposes for your entire application. Take, for example, an e-commerce system. You can have a database, your order entry could be like, have another, I'm talking about legacy applications. So you can have actually a database that only manages orders. And then you can have another, components to your e-commerce system is handling, let's say purchasing. So, well, actually I shouldn't say purchasing, but like customer base, right? So you can have another like customer database or like, people database that actually kind of, kind of manages all of your data of the people, the subscriber or customers. So all of these two, they are participating in the same transaction. Anytime, an order comes in, you need to then kind of coordinate how do all of these databases sync up all of the data, because if you're doing things here, if the thing doesn't go right, the order doesn't progress correctly, you need to have like essentially a giant synchronization to make sure all of the databases that have been touched to kind of roll back. So now, the thing is too with that, then there was a solution of using a two-phase commit protocol, so 2PC, right? So essentially too, that would be something like, as the scenario I was describing to you, we could have an Oracle database doing order entry, and then we have an IBM DB2 managing your customers, your people kind of database, and then another one too managing, I'm not saying that that's the case, but it could be, right? So then you can have also shipping, your shipping supplier, all of these trucking companies, you're managing them separately. So anyway, so with all of these, then essentially too, the two-phase commit, there's a coordinator. So think of it more like, directing traffic. And the two-phase commit essentially is a very synchronized type of way of doing things, because everything you need to do, you have to go through this coordinator, kind of this middleman. So, and as such, right, two-phase means there are two phases, right? So the first phase is like a voting type of kind of a protocol. So the coordinator would kind of first say, okay, we're doing this transaction, the order comes in, and let's kind of, figure it out. Okay, now everybody does something, and tell them all to do stuff. And let's say, by the time you're done, then my coordinator will have to then go to the order database, which is actually living in an Oracle instance, for example. Then it will say, are you done? So the Oracle database says, yes, I'm done. So pass back, right? It's kind of vote. So the collector, this coordinator would collect all of these votes and then go to the next one, the DB2, ask, are you good? Is it all good? Everything's good. So the DB2 said, yes, I'm good. And then we'll then go to the next one, so on and so forth. Now, maybe this is too theoretical to say that they all are on different databases, but it's possible, right? Even like with two, you do need some sort of way of coordinating. So that's the job of the two-phase commit coordinator. But as you can see, the drawback is that it's very synchronized way of doing things. It's very robust, things will work, but at the same time, it's slow, because everything needs to happen kind of almost think of it like sequentially. Now, the thing is too, we are assuming too much of the network being reliable, but the network may not be reliable. So you can have like the data, like one database not working. And then what happened is that your coordinator or something like the network gets dropped. So in that case, then the coordinator will have to then kind of, try to get back online and be able to kind of reconnect and then kind of say, okay, I'm in the middle of kind of receiving votes from DB2, but it doesn't work, so I have to wait. And in the meantime, guess what? Everybody else who's lining up to submit their votes will have to wait until that gets resolved. So as you can see, it's very inefficient, not very, kind of up to date, so to speak. We're living in lightning speed world these days. So anyway, I spent enough time talking about two-phase commit, but that's actually still being used. And don't get me wrong, it is a protocol that would work very well otherwise if it weren't because of it being so kind of a blocking kind of nature. So it is actually still being used today. I think even in some of the Kubernetes, for example, some of the database, I think the sharding and all of these, some of these are still actually using this protocol. So, okay, so that's that. And then let's kind of then move on to like Java, right? Application level. We're at a Java conference, so I'm referring to Java, but of course it can apply to any other language framework as well. But say for Java, we have enterprise Java Beans. So the enterprise level now is Jakarta EE. There's EJB, then EJB has stateful, stateless, and also entity beans, right? So there's essentially two. There's stateless session bean. So, okay, let's throw that away. That's not discussion here. We're talking about stateful. So there's stateful EJB. So it's basically the state of the data is being kept during the lifetime of the session. So if the session goes away, then the data doesn't get preserved. If there's no other mechanism of preserving it. And the thing is too, is that if you want to kind of have your EJB communicate with the database, then you would use entity beans. And so, yeah, so those are some of the, the options that you have in Java within like an enterprise context. And then if you're using Servlet in a web app, then naturally too, then we're dealing with HTTP session. But as such, we know that HTTP is a stateless protocol. So in order to kind of being able to maintain data in between, different requests during your session, then there's HTTP session that helps with servlets. That I'm sure a lot of you are familiar with. And now then let's take a look in like client side caching of server responses. So on the client side, then there's also the use of cookies. I'm sure everybody, if you're familiar, right, when you're dealing with web-based application, we're familiar with cookie-based authentication, and then also the token-based authentication, such as JWT, right, JSON Web Token. Now, the difference is that cookie-based is that it's a bit less efficient because then the cookie essentially only carries with it the session ID. So essentially too, you have to make this trip, over the wire from the client request over to the server and say, okay, present my session ID. So the server will look at it, it's all good. And then essentially too, then the client will then have to go back and then fetch the payload, right? All of the data that needs to be processed, whatever it is, and then make another trip over the wire and sends the things over to the server side for processing. So you can see it's a little bit of an inefficiency there. But for the JWT, the JSON Web Token, the token itself will carry with it the session information, right? The identification ID, and also the payload too. So it makes it a little bit more efficient because you're carrying the whole thing over and then ask the server to do things, and then it's all good. Then you immediately have the payload with you. So yeah, so those are some of the examples of how we deal with maintaining state, right, in the cloud. Before the cloud native days. So now let's take a look, right? Stateful microservices in cloud native environments. So as such, right, we're scratching my head. Well, cloud native, aren't we all reading it about being stateless? Everything is serverless and all that. Well, of course, it's not like truly serverless, but kind of like stateless. But the thing is, though, with cloud native, you are supposed to be stateless. In other words, and a lot of times too with cloud native, we are also talking about containers that are carrying all these microservices. So they do need to be very lightweight. They do need to be not much concern, much like a dory, right? And the fish is like, I'm gonna do things, I'm there. It's the stateless nature is very prominent in cloud native. So let's take a quick look to what is actually cloud native. That's also been a bit of a lot of I think a lot of questions, and then also people asking me as well, and especially too, it is a bit confusing. So cloud native computing too is really an overarching approach, I call it, because it's really an extension to cloud computing. First of all, cloud computing came out right in more of the 2000 kind of late 2000, the first millennium. And then essentially too, Netflix was the one that, being in the business they are in, have to handle data in such huge volume and at at really high response time is needed, right, for streaming all the video, all the media. So they coined this term cloud native. So essentially too, I look at it more like an extension of cloud computing, because in the beginning of time, right, with cloud, we were seeing more things being done on the infrastructure side. Now there's still work being done, right, on the infrastructure. There's still a lot of work, in fact, in Kubernetes, in containers, and all of these things. But of course, too, right now these days there are more kind of the shift of focus too into how do we preserve state of data? So we'll take a look at it in a little bit. But again, back to this cloud native is that we're looking at cloud native. So Netflix coined the term in early 2010s. And in fact, I think it was at a conference. I forgot which one. I should have copied it down. But somebody, I think from their leadership, right, came out and presented cloud native. And that's when it first came out. So whatever is being like kind of described as, we know the goals. The goals are to have highly available systems, very scalable and very performant. Now that rings a bell in fact too, because I was doing more of reactive systems kind of efficacy before. So to me, I was like, oh, wow, that's cool. That's kind of like similar to what reactive's goal is. Of course, reactive is slightly different, and I'll discuss about it in just a couple of slides, but let's kind of go a little deeper into the cloud native. So as such too, for cloud native, right, and how can we point folks, if you are new to cloud native, how can we start, right? So I like to kind of point out too, there are the 12-factor application, this guideline in principle as outlined by Heroku. And it's basically the set of 12, right, guidelines and best practices. The idea is to have portable and resilient applications that are well suited to be in cloud environments. So one of the factors too indicates the need, right, for self-contained services, and they should be deployed as stateless processes. So as you can see, microservices can fit this expectation very well because of the nature of microservices being kind of like small, right, self-contained and kind of in some ways, right, not quite exactly all independent, but it's kind of independent. You have your own set of resources, strictly speaking, but although I do have to say too, if you follow that too strictly, it may not be a good idea, but that will be left for another talk. But anyway, to go back to it, the spirit of microservices, small, having all of the resources. So that's the best kind of choice to use for a cloud native environment and to be containerized. So the nice thing also is that with microservices is that it's also a set of kind of guidelines, and it doesn't enforce what type of tools or libraries you should use as long as the goals are being met. So let's take a little further into the 12-factor application. As you can see, these are the 12 kind of points, right? I'm highlighting it. The code base, right, needs to be able to track it, because in any given point in time, it's encouraging the frequent updating and very efficient of your components of your microservices that are running in the runtime. So you do, and because of this quick kind of changes happening in your source code, so you do need to have good ways of managing and tracking all of your changes. So code base, you do need to have a good revision control and the multiple, even on the deployment side too, right? You do need to keep track of all of the artifacts too that are being produced. So that's one aspect of it. Then there are also dependencies, right? You need to explicitly declare and isolate all of the dependencies. You don't want things to be too tightly coupled, because it gets very hard to do things if you have to do that. And configuration, you want to store the configuration in the environment too. And then there are also backing services. All of these, all of the backing services are attached resources. You don't want to include them inside your microservices. And then the build, release, and run aspect of it too is also kind of key to kind of enabling cloud native applications to run and deploy efficiently. So essentially, that's actually point 5 is DevOps. So DevOps is essential kind of factor in a proper cloud native kind of ecosystem. And then there are also processes too. So you want to make sure that your app are being kind of execute. You want to be able to execute your app as one or more stateless processes. So it goes back to the stateless kind of requirement in there. And then port binding too, right? Then you want to export the services through port binding. Again, you know, all of these ports too are kind of easily, you can kind of assign them and kind of bind them kind of easily outside of your microservices of your whole main system. And then concurrency. Now that's important because then you want to have it, you know, the scalability aspect of it, the concurrency aspect of it too. It's also absolutely important in a cloud native environment. And we tend to, in today's world, is that we're leveraging on the infrastructure to enable that. For example, like Kubernetes, all of the cluster kind of mechanism, everything is helping you too, all the nodes and things get replicated there. So we're leveraging on the infrastructure to help us with that too. And then disposability too, number 9 here is also kind of pointing to the microservices side, is that we want to maximize the robustness with kind of fast startup and also graceful shutdown. So things have to be kind of happening really kind of quick too. So that's kind of microservices kind of fit into this kind of description. Dev prod parity. So you do want to keep all of your environments, all of these, you know, kind of development. And of course, I have done also like IT kind of deployment delivery, you know, and for example, at Chicago Mercantile Exchange, you know, kind of very fast paced and very, you know, requires a lot of accuracy in your data. Then we have like 4 different environments. And I recall, if, you know, without containers, actually, I worked at the time was legacy time, and we had different build teams that even like with each environment, they're taking care of development, some, you know, another team taking care of the QA and then staging and then pre-production, or even like 5 environments there. Then before you get to production, there are different teams. As you can see, you know, they always can get to be quite inefficient in that sense. So having cloud native containers and everything, you can actually separate them out, but all of these environments are attached with each environment. So you can kind of easily kind of deploy and start and stop that way. So, okay, so that's that. And then there are also logging, right? Logging also, we want to actually leverage on event streams, and that will be, be done described in another talk. And then admin processes too. You do want to have these management processes as one-off processes that won't interfere with your main part of your application. So that's essentially cloud native applications in a kind of nutshell. Okay, so now then kind of let's get back, right? How do we then preserve state across like session, transaction, and network boundaries in a cloud native environment? You know, how can we do that? So let's first take a look techniques and mechanisms. So these actually are not brand new. And we also just looked at it at the cloud server, client server days. We're making use of caching. We're still using caching kind of provider to do it. For example, Java, there's JCache, the specification, and there are different providers that kind of implement it. And I have a quick example to show you towards the end of this presentation, making use of JCache and leveraging on Hazelcast as the provider, and running in the Open Liberty microprofile runtime too. I'll show that to you. So that's caching. And of course, there are other kind of caching providers too. For example, I guess like, I guess even like with MicroStream here too, and they came to the Chicago JUG to present. And I thought that's a very efficient way of kind of handling very ultra fast type of caching mechanism. You can look into external other providers such as MongoDB, CouchDB, and such. So anyway, then there's also database style transactions, which I also kind of spend a fair amount of time talking about it, so I won't repeat it here. And then cookies too, right? And cookies too are kind of the mechanism. And then essentially too is a lot of the client side too also will be keeping track, through cookies. It keeps track of key kind of identification information for certain sessions, right? And then of course, now then it gets to sessions. Sessions help you too with managing state, keeping track of the state, and then also tokens. So as you can see, these are not like part of the, the microservice itself. So think of it more like, okay, these are kind of external things that help to preserve state, for cloud, for stateless, cloud native microservices. Now, let's take a look now then into cloud native infrastructure. So of course, when we talk about cloud native infrastructure, we cannot get our minds off of Kubernetes. It is ubiquitous, it's everywhere. So let's kind of zoom in a little bit, taking a look what they do to support stateful. So containers, right? Kubernetes. So there. Oh, okay. So just first talk about it too. In all kinds of distributed systems, we're looking at, sometimes distributed systems almost seems like self-service, but yeah, kind of self-directed, so to speak. But the thing is too, is that you still would need some sort of, so to speak, right, leader. The leader is there to kind of select who to do what, answer call or something like that. So it's sort of like your Kubernetes too. The Kubernetes runtime will need to have this mechanism, in other words, to kind of select a leader. So it's called leader election, this algorithm that's already built in. So you can actually use something like Apache Zookeeper, for example, is a pretty commonly used kind of a library, to manage clusters or manage like distributed systems. But the thing is too, is that if you use Kubernetes as is, or even like OpenShift, for example, and there's etcd that's already built in that helps you with kind of taking care of the leader, choosing leader, because it already has this built-in mechanism, which actually is working quite well too. So that's etcd. Now, with Kubernetes too, there's also stateful sets, which is also a feature. Essentially too, as the name implies, it is to help with maintaining data, right, in their different nodes, components across all your whole cluster. So Kubernetes also itself, on this layer has this mechanism. So in other words, with this too, it manages, right? For example, like, for to Kubernetes, he doesn't know what your specific applications are doing, but it treats it like kind of a unit. Your microservices, for example, gets deployed into certain code, into certain nodes and things like that. So with stateful sets too, Kubernetes will have this way of managing and then also helping with versioning, for example, because then we're constantly we can be like having problems with the microservices in runtime. You need to do frequent code changes, and maybe sometimes in some cases, well, God forbid, right? Sometimes we do need to test certain scenarios only in production, which actually I came across, and it's scary. But the thing is too, well, let's say in a Kubernetes kind of environment, then you will need, that Kubernetes be able to track it, because, and so that's when if you kind of configure using the stateful sets, then it can kind of help with managing all of these version changes and things like that. So then, the user, the application layer won't have to worry about. So we're relying on that to do that. So that's stateful sets. And of course, I kind of high level talk about it, but we kind of can go deeper in another talk. So, okay. And then there's also then, stateful sets is still more abstract, right? We're not dealing with the storage level. So if we kind of go a little further, then it is actually persistent volume that Kubernetes uses, right, to kind of like interact then with more of the physical storage that's underneath, right? And so I'm kind of breaking things down into kind of going deeper. Persistent volume is what you can also, in terms of like an administrator of a Kubernetes, you can kind of work with, right? You're kind of configure your persistent volume. So essentially too, if user apps, need some persistent volume, some kind of a assignment and all of these things, you can actually use a persistent volume claim to kind of present a request to Kubernetes, and then all of these things will be handled for you, kind of like, internally, right? Helping you with managing all of these volumes. So that's also another thing, but you can have certain amount of, I guess you can say like a bit of a control through the use of persistent volume to Kubernetes to handle kind of maintaining state, and also like keeping, kind of all of your data, kind of maintaining them too. So or statefulness, right? And that's what we're talking about. Okay. And then of course too, Kubernetes also has this one kind of feature. It's called like cookie or session affinity. So, and then I'm using a sticky cookie in here because it is also called sticky session. So what is sticky is? So sticky is essentially, think of it kind of used to be, right, cookies for web browser, but now we're talking about cookies and stickiness for like Kubernetes, like clustering. Because think of it, right, you can have requests coming in, and your requests can go to any one node to handle any worker node, and kind of handle your requests. But the thing is too, we want to have some efficiency. We don't want to have the same client coming in, within. We want to kind of maintain the context. So essentially too, we can leverage on this sticky session. So essentially, Kubernetes can kind of know that, okay, you asked me before, so I will ask the same node to handle your request. initialization time to have your your particular kind of node to initialize itself to kind of say, okay, can I help you again? It's much like us, right? When we go and let's say we call up, the doctor's office, a hospital or something, ask for something, you talk to this person, right? And say person A, and they help you and they said, okay, call me back. And of course you want to talk back to the same person because he or she already knows what you're talking about. So that's essentially is the same thing, is that Kubernetes has this built-in mechanism whereby it can kind of have this sticky session for you. So then when you go back again, right, it's the same kind of one that's servicing you will reservice you again. It should be a lot faster. Okay, so that's that. And now I tend to talk too much. So let's kind of go into a bit more programming kind of design aspects. So now for doing like stateful work, I think everybody, maybe if you're familiar, right, with microservices, you may be already familiar with the Saga programming pattern. It is a very popular, I'd say it's probably the only pattern that we can be leveraging on to do stateful microservices programming. And of course, too, Chris Richardson, who is a well-known microservices expert, he has actually a site to microservices.io, and he talks about Saga pattern. But yeah, so let me kind of bring this up in here. And also, too, as you can see, there's also Saga pattern. Okay, let me kind of first talk about it for what it is. So Saga is essentially helps you to manage your transactions. Think of it like what used to be two-phase commit, like coordinator. It's not really the coordinator, but it's actually a pattern, right? That encourages you, to do the work the way it is, so then you can enable like transactions to be done in a highly distributed environment. And so essentially too, it helps so that transactions that are spanned across multiple services, right? There are multiple databases, whatever it is a highly distributed way. You can and kind of employ this technique to do it. And the thing is too, is that with Saga, there's this concept of compensation, and there are like no rollbacks like what database used to have, right? Although the effect is kind of similar to a rollback, you just want to say, if something doesn't go right, I want to kind of go back to where it was before. So it has that. However, it is actually called compensation. So in some ways, to think of it as a change of thinking also too, is that it's a forward strategy. So rather than saying rollback, go back in time, we're going forward. We don't care what happens. Let's go forward, but we'll fix the thing and makes it kind of restore the state, to where it was before. It's kind of think of it like that. So now there are two ways of sagas to doing sagas, coordination sagas. One is called choreography, which is actually event driven. And then the other is orchestration. So with orchestration, it's like sort of like, the principle of two-phase commit, and you need an orchestrator, a middleman in there. Although it's not, like two-phase commit, because the thing is too, is that it doesn't encourage like blocking or synchronous way of doing things. So, okay. And then also I wanted to bring up is that on the right-hand side with this running man, is actually, there's also a long running action. This pattern is essentially a Saga interaction pattern. And it employs the compensation model for doing like, compensating if something doesn't go right. And there's some example too. A library implementation is from MicroProfile. So this is very new. It version 1.0 just got released back in May of this year. So it's a fairly new feature in MicroProfile, or kind of fairly new kind of major feature 1.0, because previously it was kind of more beta version. So if you haven't worked with it, that might be worth kind of checking into. But in the meantime, let me kind of go quickly to an example. Okay, and by the way, these are the pictures I was showing you. That's Chicago. That's where I'm based in, although currently I'm not in Chicago, but I just thought I'd show you. Okay, let's go here. We're talking about Saga. So, okay, so that's Open Liberty, but let's kind of take a look into this. So I actually have this design. This I'm hoping to at my next set of talks, because this talk is a bit new for me. I just kind of started doing this 5 months ago. So I'm actually having this design that I will be implementing and using MicroProfile LRA. And if you're interested too, you're welcome to join me too. And so let me talk a bit about, so much talking about Saga. So let's kind of take a look at an example, at least kind of on paper. So this is actually making use of a choreography, event-driven approach, Saga approach. So I'm gonna wanting to do a shopping cart, an order processor, very simplified. Again, this is very simplified, but I want to illustrate the Saga approach. And so let's say we have order generated is a Kafka topic that actually receives all of the orders, new orders that come in. So my order microservices, microservice will actually be the subscriber that subscribes to the Kafka producer message. So once the order gets generated, my order will then do something about this order. It will kind of set up, your data, all of these things in the database and all of these things. And then at the same time, it created this order, enter that into the database and generate an order created event. So this event in turn are being subscribed to by two other microservices, inventory check and credit check. So these two will subscribe to it. And then essentially too, once you do an order, then you need to check to make sure in your warehouse you have enough merchandise to meet the needs of the consumer, the consumer requests. And then also then you want to do a credit check. You want to make sure that the buyer has the funding, right? So these two will be busy checking everything. And in the meantime, too, it also kind of sends back, kind of a status back to order. So you could be saying that, okay, order being processed, something like that. So now, in the meantime, inventory check comes back and then it's all checked. Let's say everything's all good. I have, let's say I'm ordering, like a bag of apples. I have that. And so order inventory created and is checked. Then basically, then it will be then kind of subscribed to by the payment processor. And also to order inventory check will then go back with an order inventory validated back to the order microservice. So as you can see over here too, right, on the left side, it's all the set of like statuses that I keep track of my order. And in the meantime too, my credit check too, now usually that would take a bit more time because maybe you have to contact your payment authorizer, payment processor. Now I'm kind of simplifying too, but there could be more steps, but you get the point. So the thing is too, let's say, I check the credit, this buyer has enough funding and is good standing. So then I will say order credit checked. So then the payment processor who is subscribing to these two events will then be signaled, right, to kind of go ahead with processing the payment. And credit check too will also go back and tell the order microservice that order credit has been checked. Now, as you can see too, over here in the bottom too, I have compensator microservices for doing rollbacks, but that's left to another discussion because compensator, you do need to write the code in order to kind of handle if anytime something doesn't go right. You do need to do so to speak, like forward strategy, but to sort of like restore it back to where it was. So that will be handled by the compensator. Now, in the meantime, while we're talking, the payment processor has processed everything, is all good. Then it generates an order paid event that will actually be subscribed to by the shipping processor. So then the shipping processor will then go and notify the supplier, fetch the thing, and then ship it to the destination. All these things. So in the meantime, too, payment processor will also need to come back and say order is paid and telling the order. So yeah, that's kind of illustrate to you how a Saga pattern can be used, and this again is a choreography model, not the orchestration. I probably will have an orchestration at some point later too. So if you're interested in joining me to implement it, I will be very happy to do so. So, okay, so let me then go back to my talk here. And how about reactive, right? Let's quickly talk about reactive systems and the reactive manifesto. So as I mentioned, right, cloud native, the goals are highly available, performant, and scalability. So we have all three. Let's look: responsiveness, elasticity, resiliency, all of these kind of goes hand in hand with the cloud native goals. One more thing about reactive, of course, is not the same, but reactive too as such, right? It handles data as streams. So that's like one major difference right now. Of course, when Project Loom comes, it could be slightly different. We don't know yet. Handles data as streams. And also as such, it's encouraging, is very message driven in nature. Message driven is slightly different than event driven. Message driven requires like a receiver and a sender, much like an envelope. You are sending, like sender sending something to a receiver like that. So that's kind of like a quick note about reactive systems, and also reactive is guided by the reactive manifesto. That's also a very interesting way. You can always do your microservices and implement, just do cloud native microservices, not really using the reactive approach of not using streams. So it's kind of a flexible, or at this point, this is what you can do. So, all right, some code example. I know I only have maybe like 5 minutes, and let's quickly kind of bring it up because I talk about open liberty, right? I also work with the Open Liberty team and the microprofile team. So as such, right, open liberty is like I'd say one of the best, right, or the best, I should say, like library that you can leverage on to build very cloud native, efficient application, and that's also standard compliant. It works very well, integrate very well with microprofile, and also microprofile also implements a lot of the Jakarta EE specification. So it's kind of nice too if you know that you are developing some application that are standard compliant, because if there's a need, for whatever reason, you need to change or something, the framework, it will be easier. Or you want to integrate with something that's new that coming, into your organization. If you kind of comply with some specification, it always makes the migration transformation a lot more smoother. So, okay. So we'll have the link for you too, but let's kind of quickly take a look. Let me kind of go back there. Okay, so Open Liberty. Okay, so if you go to openliberty.io, now I have this link too on my set of slides, so don't worry about copying if you don't have it. But the thing is, go to this link, and then if you go to Get Started, actually Get Started, you can use the Starter app. If you're kind of wondering how to work with it, you can do that. And then you can, the thing is too, I want to point out, this is the treasure trove, because you can try out all of these different lab exercises in the guides. And today too, if you go into persistence, so persistence in here, this is the exercise caching, and caching HTTP session data using JCache and Hazelcast. So if you click on that, you can actually follow these, and basically too, this is also a very kind of a basic shopping cart kind of example that you can try out. So let me kind of, I actually wanted to do this one thing. I'm wanting to kind of bring it over to you. Oops, and let me kind of do it like that. I should have done that. Okay, so let me kind of, if you're welcome to do that, and I can kind of quickly send it to everybody too. And again, I have this. I just sent it in the chat too, if you want to start looking at it and try it out in your leisure time. So this is the one. So in order to do that, we already have some ready-made kind of the example there too. So let's say, and I have to look for this thing, then I can move. Sometimes, oh, here we go. Okay, now you can kind of like, it shows you too, it's really step-by-step. The idea is to illustrate JCache using Hazelcast in this case. So, and I have, how much time do I have, Sebastian? I'm sorry, I kind of lost track of time. So, because I can also do this and then do it later too. But the thing is too, that's the idea. If you want to like quickly try it out, right, and if you clone this, right, you clone the, which I've already done, and then you kind of CD to guide sessions, there are two directories. One is the start, and then the other is finish. So if you want to just kind of quickly take a look at what it looks like, you can actually just go to the finish directory, right? If you could do an ls in here, you see that there's already, I have the POM file ready, and actually I've already built it. So in order to do that, right, this is all Maven, but we will have Gradle as well, if you're a Gradle fan. So you can do a Maven, this is Liberty, and then you can do a run, or you can, better yet, doing a dev mode. I wanted to point out the dev mode is so nice because it essentially too, if you make any changes to your code base and configuration, you don't need to reboot your system and rebuild. Everything is kind of, think of it like hard deploy. So, okay, I have 5 minutes for question. Okay, thank you. Okay. Okay, all right. I will be quick, and maybe if I can just quickly show this, and I can answer questions too if anybody wants to ask question. In the meantime, while this is building, I just thought I'd quickly kind of show this. So, I have 5 minutes. Yeah. So is it, Sebastian, I can have 5 minutes. Well, I was hoping this could go a little faster, but okay. Here we go. But folks, you can try it out too. Now, the nice thing about this too, as such, right? You do need to have your JDK in a path and have Maven. So that's the one thing. And also, if you kind of get to deploying to Docker, you will need Docker desktop as well. So those are the 3 things you will need. But as you can see, how nice, this actually is already started, is running in dev mode. If you see that the default server is ready to run a Smarter Planet, that means your server is up. Okay, so I'm doing some magic in here, and let me go over here, right? Let me kind of go over here. Now, this, I'm just doing magic. So your application is ready, but the thing is too, let me go back to that one. Okay, then you should be able to see this. Let me kind of do that. Now, it makes use of MicroProfile, integrates very well with OpenAPI. So as you can see too, this is very nice. In the code there, as you can see, we make use of OpenAPI of the annotations too. And it makes use of JAX RS for the RESTful API. So here too, you can try it out, right? We have this guide session default, right? We have 2 things. If you do a post, it's essentially, or doing a get first. Let's try it out. We haven't added anything to the cart, so it's 200. Now, if we do a post, then we can try it out. Essentially, too, this one will allow you to say, we buy some oranges, something, orange, let's say orange, and let's say $1.50 something. So execute. So as you can see, then over here, code is the return code is 200, and then it says orange has been added to your cart and costs $1.50. So now if you go back to get, and then you can just say, try it out again, execute. Now you can see the code will return 200. And the response here, as you can see, the body will then show your cart having orange, and it's $1.50, and the subtotal is $1.50. So I know this is kind of like a really quick way, but the thing is too, is the nice thing about this is that as such, right, I was showing you that example. So you're welcome to kind of work through this example and take a look at it, for session persistence using JCache in this case. I just don't have time now to get into more details, but I actually have another session elsewhere too that I'll be doing more things. So, but the thing is, I do need to kind of go into here, back here. I also have an example working with Stateful Open Liberty application in Kubernetes, and that's making use of the Nginx for the ingress to controller and Stateful set in Kubernetes. So I'll have these slides ready for you. And then I want to thank you. And I'm just assuming folks may want to ask some questions. So I'll go into some resources. And I just want to list out to my discussion about Saga, the Open Liberty session persistence, and the Stateful Open Liberty application in Kubernetes. MicroProfile LRA, some, all of these things, and the IBM resources, and also my live stream on Twitch. Today I won't be doing it, but next week I'll be back on Wednesday. I'll be actually talking about Java and cloud native and many different things too. So about 1.5 hours or so, 1:30 US Central Time. So twitch.tv IBM developer. And then also please join some of our expert TV and meetups too. And we are also on meetup.com. And I wanted to say too, please join my Chicago Jug too, if you'd like to. We are also sponsor community partner with this conference. So please sign up for IBM Cloud, and we have free trial of OpenShift if you sign up for some of our free workshops. So, and then with that, I think I probably should close because I was told that there's already another speaker waiting in line. And so thank you very much. And I want to invite you, if you like to continue the conversation, please join me on Discord. I'm always reachable too on Discord. I have folks follow me on Twitch too, and we're kind of forming a nice community to share knowledge too. And then you can also follow me on Twitter, on my LinkedIn and my GitHub, and also my dev.to profile too. So with that, thank you very much. I apologize if it's a little bit rushed towards the end, but I'll be very happy to answer questions on my Discord, join me on Twitch and my CJARC. So thank you. And thank you, Sebastian, for all your help too. Thank you. Yeah, so.